So our essential question that we are looking at is, how does the arrangement of the periodic table reveal the structure and characteristics of each atom in the universe? So what we're going to be looking at today is coloring your periodic table with different colors and categories and doing a few things on that periodic. Our essential question for this week is, how does the arrangement of the periodic table reveal the structure and characteristics of each atom in the universe? So really what we're going to be taking a look at is the arrangement or the organization of the periodic table, not just one of the boxes that tells us the structure of the atom, but how is the periodic table itself as a whole organized or arranged so that we know the characteristics, or another word for characteristics is properties, so that we know the properties of every single atom that's known in the universe as it's shown on the periodic table. Well, we already know that one of the ways that the periodic table is organized is by groups and periods, and that elements in a group or a column share similar properties, which means that if I'm looking at the atoms that are in one column, one group, that means that everything in that group must share similar properties or similar characteristics. Couple of things that you're going to be doing. There are 3 things that you need to do on your periodic table in your science notebook. You need to number and label the groups and the periods. So if you look at the groups starting at the top, this would be group number 1, 2, this is group 3, 4, and so on, all the way over to group number 18. You need to number each one. You also need to number the periods. The periods, remember, are the rows from side to side. So this would be period 1, 2, 3, all the way down to period number 7. Don't worry about numbering these periods down here, because actually, if you look at the atomic numbers, this is a group that should go right in here. Look, this is atomic number 55, 56, 57 is down here, 58, 59, all the way to 71, and then he picks back up right here at atomic number 72. The same thing goes for this row. 87, 88, 89 is down here, all the way to 103, and then 104 picks up right here. So really, this is all part of period 6 and 7. What they did was they just took a section of the periodic table and they put it down here. Otherwise, the periodic table would be way too long and would not fit on the page. I also said that you needed to label the groups and the periods. I need to know on your periodic table that you know the difference between a group and a period. You're going to color the different categories, or as some people call them, different families, and make a key for the colors, which means key means that you tell me what the color red represents. So the key that you're going to make can be either at the top or it can be on the bottom, wherever you have space on your periodic table page. But I'm going to walk you through what you should be doing, or what each color should be. Group number 1 is going to be called the alkali metals, and we're going to color it red. Now you have to be careful with this group, however, because hydrogen is not an alkali metal. Halogen will actually be colored green along with the other nonmetals that are over here on this side: carbon, nitrogen, oxygen, and these 3 down here. The reason why hydrogen is grouped with the rest of the alkali metals, however, is because hydrogen, like all the alkali metals, have 1 valence electron. This second group right here is the alkaline earth metal category or family. We're going to color this light blue. Groups number 3 through 12 are the transition and other metals. These are the transition metals. You are going to color these yellow. Now here's where things get a little bit tricky. The metalloids are touching the zigzag line that you can find in your periodic table in your textbook. The metalloids are going to be colored purple. The nonmetals, like I said, are green right over here, plus hydrogen. And then we have the halogen category. The halogens are only 4 elements right here in group number 17. The final group is, I'm sorry, not the final group, the group 18, the last category over here, is called the noble gases, and we're going to color that gray. Now here's kind of the tricky part. These right here, dark blue, we're going to color, and the key is showing that these are the poor metals. The reason why things get tricky is because of these elements right down here. These are actually brand new elements that have been created within the last few years that we know very little about. So even though we can figure out the structure of the atom with the valence electrons and all of that, so we've put it down here and the number of protons, we actually don't know if it's a part of a metal category, or if it's a halogen or a metalloid, or if it's even a noble gas. And so even though they've been put down here, we're not going to color these elements because we don't know that much about them. A few things that are interesting to note is everything here in group number 1 shares the similar property of being very reactive. I'm going to type that instead of write it. Reactive meaning explosive, or it always wants to bond with another atom to make a molecule or a compound. That's because everything in group number 1 has 1 valence electron, and it's constantly looking for another atom to bond with. Also, another category that's very reactive would be the halogens. The halogens have every electron here is 1 shy of having a full electron shell. So like we talked about the other day, sodium has 1 valence electron and likes to bond with the halogen chlorine because sodium has 1 valence electron and chlorine is 1 electron short of having a full valence shell. So the alkali metal group and the halogen group often will bond together because of their valence electrons. That's just a little bit of the properties of these elements. Pause this as you need in order to color and get down the notes on your periodic table that you need.